Okay, good morning, class. Today I'm going to show you how you're going to complete the mineral lab. We have a lot of information that you have to look through to try to identify each of these minerals. The good news is I'm keeping it kind of small. I believe there are only 10. Yes, only 10 minerals available to you in this lab. Here's a little flow chart to kind of help you understand how you're going to get to the point where you can identify each of these minerals. And so basically they're going to go through several different properties, and you're going to try to determine what that property is, and that should lead you to the correct name of the mineral. So starting at the top of this flow chart here, you're going to look at the luster, which is what type of shine does it have. Is it a non-metallic luster, which looks more like a just a standard crystal, almost like this quartz here? Definitely not a metal, just like a glassy kind of shiny crystal color or reflection. Or is it going to be something that's more metallic? Metallic can be anywhere from like galena here, which definitely has a metallic kind of shine to it, if you can see that. Or pyrite, which is also a metallic type shine. There's a different type of piece of pyrite. Very much looks like a metal. One of the bad parts about metals is they can also have dull appearances. This is hematite, and so not much shine going on right there. Just kind of a reddish brown color. And then magnetite, which is a dull black. This one does have a little bit of a shine to it, but not a whole lot. So that's your first thing. Is it non-metallic or is it metallic? And then they ask you about the hardness. Is it soft or hard? They don't really ask this for the metallic elements because most of the metals are going to be hard. If they're a metal, they're going to be generally harder. There's not too many soft metals. Then they ask, does it have cleavage or no cleavage? This may be difficult to determine. I'm going to show you a couple examples that do and don't. Then they're going to ask you about the streak. And one of the things you're going to be able to do is take a streak plate and actually rub the mineral across the plate to see if there's a streak left. And so I will show you that as we go through some of the minerals. Does it have any special properties? So for halite, which is essentially table salt, it will have a salty taste. Muscovite and biotite will have thin sheets that they break off into, and that is because of the cleavage. Calcite will fizz with acid, and I will show you what that looks like. And there's not a lot of other special properties. Galena is very heavy, but the piece that we have is actually pretty small, so you may not be able to feel that. But it does have a higher density, so for that small piece, you might be thinking, this is a pretty heavy piece. So what you will do if you're in class, you will have a sheet like this that basically shows you all the sample numbers. For the lab itself, which I will record in a different video, I will show you all the samples and give you a good idea of what they are and what their properties are, and it will have a number associated with those, so you should be able to fill this out. And then it's just going to have on Canvas questions that you can answer about each sample. What is the luster? What is the hardness? Is there cleavage? What color streak is there? What special properties did you notice? And what is the mineral name? The mineral name will be the most important, but you should be, if you get the mineral name right, you should be able to get all the other properties correct. I will provide you with a copy of the Mohs hardness scale, which shows you 10 of the corresponding minerals of the Mohs hardness scale, the tools that you can use, including your fingernail, which is generally a 2.5, a copper penny, which I have here, is about a 3.5, knife blade, which is 5.5, a steel nail, which is 6.5, and I don't have a masonry drill bit, which is 8.5. But we do also have a glass plate, and you can scratch the glass plate and see if it scratches. That it should be about a 6.5, I believe. Oops. No, actually, the glass plate is a 5.5. You can see that. So let's go ahead and get started. I am going to work my way from left to right on this list. So I'm going to start with halite, go to muscovite and biotite, then calcite, feldspar, quartz, hematite, pyrite, galena, and magnetite. And so if you look at this list and you need to skip back and forth to try to find a specific mineral, you can know that I'll be going in that order. So to start off with, I have 2 pieces of halite here. Something that halite does, sometimes, not always, is it has this nice 90-degree cleavage planes. And this is actually kind of difficult to see. You can see right here at this corner, there we go. This is a nice 90-degree angle from this plane to this plane. And it's kind of hard to see unless the light shines on it just right. This angle here, there we go. This angle here is a nice 90-degree angle. And so sometimes calcite, or halite, I'm sorry, will come out in cubes. Sometimes it comes out in bigger chunks. And sometimes it just comes out in nondescript pieces like this that don't really show any of the crystal faces or the cleavage. So this is just a kind of a chunk of salt. The one thing about halite is its special property is it tastes like salt, because it is salt. So if you go ahead and lick this, which obviously you won't be able to do from home, and I'm not recommending you do in the lab either, due to the current pandemic going on, it will taste salty. And when we actually do the lab and I make the lab video, I'll go ahead and tell you which samples taste salty and which ones don't. Another thing about halite, grab my sheet here. Halite is relatively soft. If you look at the flow chart over here, halite's going to be under the soft minerals, and so it should be pretty easily scratched. I don't know that you'll be able to scratch it with your fingernail. The hardness is about a 2.5, and so generally it's going to be kind of tough to scratch this with your fingernail. I didn't get any scratch with my fingernail there. But if I take a penny, which is a 3.5, push down a little hard and kind of scrape back and forth, what you'll see is I created a little scrape there. And the good test is always going to be, see if you can rub that away. Some of it came off, but you can still see the little scrape that I created. And so this mineral is softer than a penny, so we know that its hardness is less than 3.5. And then along with the taste test and the fact that it's clear, you should be able to determine that it is halite. So next on the list is going to be muscovite, and I'm going to do muscovite and biotite together. The special thing about muscovite is it's going to be soft, it is going to have cleavage, and it's going to show up in thin sheets along with its twin biotite. The only difference between muscovite and biotite are that muscovite is a light color, biotite is a dark color. And so we actually have these 2 samples here. They're pretty shiny. It's almost like a metallic shine, but you can feel that they're definitely plastic, and this actually just accidentally happened. It broke off in this very thin sheet. You can see how thin this is, about the thickness of a piece of paper, maybe a little bit less. It's flexible in these thin sheets. You can bend it, and it won't really break. It will break pretty easily, but it is bendable. And depending on the piece you have, here's another piece, it can also be translucent. And so you can see my finger through this piece of muscovite here. And so if you ever see the very, very thin sheets that break off, or you see a mineral that looks like from the side it has very, very thin sheets, that's likely going to be either muscovite or biotite. Muscovite would be the lighter colored one that looks more silver. Biotite is going to be the darker one that's almost like a very shiny black color. So those are your 2 samples here. Now, moving on to calcite. Calcite is somewhat tough to determine between halite and calcite. Calcite is going to be a little bit harder. Generally, calcite is a 3, but if you're using the penny, you're still going to be able to give it a scratch, and that scratch is going to stay there. One thing that calcite does that halite does not do is it fizzes with acid. So let me get my little acid dropper. If you ever want to test this in class, just ask me. I'll bring you a little acid dropper. See if we can see this. Put a drop on there and you can see the bubbles. I don't know how good the sound is on this video, but you can also sometimes hear the bubbling. And so calcite will always fizz with acid. If you ever have any rocks that have calcite in it, you can drip the acid on it and it will fizz as it creates a chemical reaction and releases CO2. Another thing about calcite, if you have a nice sample, this is a sample that does not show any of the cleavage of calcite, so it just kind of looks like a rock. It will also fizz with acid. Unlike halite that has the 90-degree angles, calcite has angles that are not at 90 degrees. And you can see this is not quite a right angle. It's kind of inclined there. And so that's going to be your main visual difference between halite and calcite. The halite comes in at 90 degrees. The calcite does not. Just to show you, here's a non-clear sample of calcite. And you get that same fizzing and bubbling as the acid reacts with it. Okay, so moving on, next we've covered our light colored minerals with cleavage and our dark colored minerals with cleavage that are soft. Now we're moving on to our non-metallic hard minerals. Actually only one of these has cleavage, feldspar. The quartz does not. The feldspar is generally going to have a light streak, while quartz is actually harder than the streak plate itself. So this is a sample of feldspar. You can see in a couple places that it does have cleavage. You can see right here, see how this whole thing is shiny right now. That's a nice flat plane, and so that's a plane of cleavage there. You can also see from the side here, this is a nice flat plane right on top. And so this is feldspar. It's usually a lighter color like a pink, or here's kind of a light white to light blue color. Both of these are going to be pretty hard. I can take the nail and try to scratch these, and they're not going to leave a mark. You can actually see a dark mark here. That's metal coming off of the nail as opposed to the nail scratching the sample. And if I wipe that, it will pretty much just go away. So this is feldspar. You can take a streak plate, grab a dark streak plate. I'm going to set this down on the table, push down pretty hard, and scrape across it, and you can see it left a nice white streak behind. So that's what they mean when they say that feldspar has a light streak. So this is the streak line, has a light streak. Quartz is actually going to be just a little bit harder, and so it's not going to leave any streak behind on the streak plate. It's actually harder than the streak plate, so it will scratch the streak plate as opposed to crumbling into dust. So this is your feldspar. Here's another similar piece of feldspar, and if I did the same thing with the nail or with the streak plate, it's not going to leave any marks, and it's going to leave a white streak behind. Feldspar, along with quartz, as you can see the quartz here, are two of your main constituents in granite. So if you have a granite countertop, one of the reasons we use that is because it's very hard. And so the two minerals that go into that, feldspar and quartz, or two of them, are very hard. So that's a good attribute to have in construction materials and in countertops. Here's a nice piece of a geode. These are a lot of different purple quartz crystals. Quartz also can show these six-sided crystals. This is actually how it grows. These are not cleavage planes. So if you see it in profile here, it looks like a hexagon. 1, 2, 3, 4, 5, 6 sides. and sometimes even comes to a nice pencil point. Here's a pretty large crystal of quartz. You can see from this side you have the 6 sides, and it comes to a nice, almost like a pencil point here out of those 6 sides. So that's a pretty big quartz crystal. Quartz is going to be pretty hard. Here's a non-crystalline piece of quartz. We just call this massive because it doesn't really show any of the crystal faces. I'm not going to be able to scratch this with a nail. Again, it's just going to kind of leave a dark mark where the nail rubbed off a little bit. And on this one, I'm not going to get any streak on the streak plate because the quartz is actually too hard. And so one thing I can do is scratch the glass with it. That's another way that you can test for hardness. I'm going to put the quartz down. Let's choose a part. Right over here you can see there's not really a scratch there on this glass plate. I'll set it down. Do it where you can see it. Push pretty hard. Drag it across the glass. And now you can see the scratch that I left behind. And I can wipe it away a little bit, but you can see there is still a scratch there. So it's harder than 5.5 on the glass plate. One way you can tell quartz and calcite apart, the calcite will fizz with acid, the quartz will not. And generally the quartz is a lot harder, so the hardness test should help you out with that one. One of the things to be aware of, also on this, I guess it's not on the... These won't be in the lab, but there's another mineral, fluorite, that actually is sometimes kind of difficult to tell apart from quartz. They can have similar colors, they can look similar sometimes, although fluorite doesn't have the same crystal faces. Fluorite in general is a little bit softer, and so if I work at it a little bit, I can actually make a scratch in fluorite with a nail. But I just wanted to show you with quartz, you can have it almost any color. The same thing with fluorite. I've got blues and greens, reds. You can have black fluorite. You can have black quartz. And so just visually, without really doing any scratch tests or any other types of tests, fluorite and quartz are kind of difficult to tell apart sometimes. Okay, moving on. I have 4 left. These are going to be my metallic elements. So I'm going to go through hematite, pyrite, galena, and then magnetite. Almost done. So first, we start off with hematite, and I probably mentioned this in one of the other lecture videos. The word hematite sounds like hemoglobin, and so it's actually named after the reddish color that it has, which is similar to blood red. Some samples look more black. This one does have quite a bit of red in it. It's probably been oxidized. But one of the most important things is its streak. If I take this and rub it across the streak plate, it's going to leave a nice reddish brown streak behind as it powders away. So that is a really easy way to figure out what is hematite and what is not. The next one on the list is pyrite, which hopefully you know is fool's gold. And so that is the shiny gold color one. They can have massive crystals like this. I actually have a couple just random pieces of pyrite. They can also form nice crystal faces. And so this is a pyrite cube, almost. It's a little bit elongated. This was not cut this way. This actually grew out of the ground just like this. This is one of the crystal faces that it has. And so pyrite has several different ways that it can form. One of the things you can help identify pyrite is its streak. Unlike gold, pyrite will have a black streak. So if I draw this across here, you can see compared to the mineral, this is a black streak and not like a gold streak. Also, pyrite is a lot harder than gold. If you've ever seen the Olympic athletes bite their medals after they win a gold medal, That kind of dates back to when we weren't really sure whether we were getting gold coins or not, and so you give them a bite. Gold is actually pretty soft, and so your teeth should leave a slight indent in a pure gold coin, which is not what the Olympic medals are, but they still do it out of habit. So we've done hematite, pyrite. Now we're going to get to galena. The special property for galena is that it's very heavy. It's this dull gray color. It almost looks like pencil lead kind of color, but more shiny. It does form these kind of cubes, and so this is not cleavage. This is almost a cubic crystal pattern that it forms. It wasn't cut this way. But you can see the nice shiny parts on it. Galena will also leave a dark black streak, but that's to be expected because that's kind of the color that it is, this dark gray, dark black. And then lastly, we have magnetite, which, if you see them in person, does have a very different look than galena. Galena is more this light gray, kind of pencil lead look, where magnetite is more of a black and can kind of be rusted. But as you might have guessed from the name, magnetite is magnetic. This piece is pretty old, and so the magnetic properties are pretty weak on it. But if you take something kind of light, like a staple, it will hold the staple to it a little bit at least. So this piece is still slightly magnetic, although it's not super great. But yes, magnetite is magnetic. All of these are pretty hard, so you can do scratch tests on them, but it may not be super conclusive. So along with the lab, once I make the lab video, I will give you this chart to kind of help you work through it and try to identify the minerals. I will give you another more detailed chart that has all the minerals that we're going to be using and maybe a couple more. I have deleted quite a few out of it. But it will have the color that you can expect to see, the streak, if you do it on the streak plate, your hardness, what kind of crystal shapes you might have, if there's cleavage or not, and any other observations you might see about the rock. And so this may be a little too much information, but I'm still going to give it to you, and maybe it'll help you out with the lab. I will also provide you with the Mohs hardness scale, so you can use that, and the information you need to fill out the lab assignment on Canvas. And so I will post this in another video which shows you the actual samples that you'll have for the lab, and each of them will be numbered, so you can go through and try to identify each of them. You'll probably want to have this video open along with that video, because I did show you all of the samples that you will be seeing in the lab. Some of them will look a little different, but all the minerals in the lab were represented here today. So if you have any questions, please email me and let me know. If you have trouble watching this video, I guess you won't be hearing my voice right now, but also email me and let me know. And I will see you or talk to you tomorrow. Thank you.